फेसबुक पे आ गया। फेसबुक पे आ गया।
अस्सलामुअलैकुम।
वालेकुम सलाम जावेद साहब, कैसे मिजाज हैं सर आपके?
अल्हम्दुलिल्लाह अल्हम्दुलिल्लाह। सुनाइए।
माशाल्लाह आपकी आवाज बिल्कुल ठीक आ रही है, और आप बस जरा एक बार शेयरिंग चेक कर ले मेरे साथ।
एब्सोल्युटली, लेट्स सी। जी आपको नजर आ रही है स्क्रीन मेरी?
मुझे अभी आपकी स्क्रीन नजर नहीं आ रही, मैं जरा देखूं मैंने अलाउ भी किया हुआ है कि नहीं। एक
जी
मिनट
जी।
जी किया हुआ है, आप करें शेयर।
अच्छा,
हाँ जी आ गई है, आ गई है।
ये फुल स्क्रीन नजर आ रही है आपको?
जी जी आ रही है जी बिल्कुल।
अच्छा अच्छा अच्छा।
आप इसको जूम कर सकते हैं, वो दो स्लाइडें आपकी एक वक्त पे नजर आ रही हैं। गुड
अच्छा, तो
प्रैक्टिसेस।
मैंने गलत स्क्रीन शेयर कर दी है, फिर लेट मी जस्ट शेयर दी अदर स्क्रीन। लेट्स सी कि कैसे स्टॉप अच्छा, या मैं इसको लेट मी एस्केप फ्रॉम देयर, इसको इधर ले आता हूँ। जस्ट गिव मी अ मिनट।
टाइम है अभी, काफी टाइम है, 15-20 मिनट है अभी, नो इश्यूज।
अच्छा हाँ ठीक। होपफुली अब आपको आ रही होगी।
बिल्कुल ठीक है, बिल्कुल ठीक है सर, बिल्कुल ठीक हो गया।
चलो एक्सीलेंट।
यस बिल्कुल ठीक है जी। अब आप अनशेयर कर दें, ताकि क्योंकि ये फेसबुक पे भी जाता है तो मैं वो दूसरा बैनर लगा दूं।
ठीक है भाई, एक सेकंड, लेट्स सी के
जी जी अनशेयर हो गया है, थैंक यू।
ठीक है।
बिल्कुल ठीक है जी। मैं इस पे भी अपनी स्क्रीन शेयर करने लगा हूं, ताकि हम पूरे की इंशाल्लाह 5 बजे पाकिस्तान टाइम पे स्टार्ट करेंगे।
ठीक है।
आपकी तरफ क्या टाइम है इस वक्त?
इस वक्त जनाब 6:50 हुए हैं।
हाँ जी, बस 7 बजने वाले हैं ना आपके, बस ठीक हो गया सर, ठीक है। हाँ हाँ भाई, एक मिनट आप ध्यान से 5 बजे के बाद लोड करेंगे। जाती है 5:15 तुम जनरेटर ही रखो ना। हाँ हाँ, ये कैसे चलाएगी, किस पे है? भेजी जाएगी, भेजी जाती तो है। नहीं यूपीएस चल रहा है ना, मैं तो नहीं डिस्कनेक्ट करता अभी बस। लेकिन जब वो बिजली चली जाए तो तुमने वो चला देना।
यार ये लाइट चली गई तो मैं किधर बवाऊंगा फिर। अभी लाइट चली जानी है 5:15 बजे।
यार लाइट चली गई, सोलर पे चलता था यार।
और सोलर बंद हो जाना 5:15।
सोलर बंद हो जाने तो अंदर चली
किधर
यूपीएस से चल रहा था।
किधर?
हाँ अंदर बैग में, अंदर वो पीछे सोच लगे, सोच पीछे पे लग गया हुआ।
हाँ
यूपीएस जितने कंप्यूटर नहीं किया उतना उनके पक्के में दोनों कर सकते थे।
सही।
जी जावेद साहब, डॉक्टर वाहिदी इज ही कमिंग?
जी, he's here actually.
अच्छा ही इज विद यू, ठीक है जी।
He just stepped out of the room.
ठीक है जी। वन मोर थिंग, क्वेश्चन आंसर्स जो है वो स्लाइड बाय स्लाइड है कि एंड यू वुड प्रेफर एट द एंड 20 मिनट?
We would prefer those at the ends ताकि वो, and we can always, जब वो पूछते हैं तो we can always go back to those slides.
हाँ जी, नहीं वो अगर बहुत ही नेसेसरी हुआ ना तो दैट आई विल चेक। अगर बहुत जरूरी हुई तो मैं आपको इंटरप्ट कर दूंगा, वरना ताकि स्मूथ रहे लेक्चर।
ठीक है, एक्सीलेंट। आइए देखिए। Should we tilt the camera slightly this way? Okay, I'll be center में आज. I don't know whether this has the tilting capacity or not. चलिए मैं इधर हो जाता हूँ थोड़ा सा. हो जाए, move in.
अस्सलाम वालेकुम डॉक्टर साहब, हाउ आर यू सर?
Walaikum assalam. We are speaking through computer video, computer audio, so we have to talk one by one.
ऐसा ही है। Mia Jauddin has joined us. I think he's just connecting. अभी उसकी वीडियो नहीं आई, लेकिन he's there.
It's a blessing to have him here now with us.
हाँ जी, I think he is somewhere there in either in Canada or in US.
अच्छा.
He's not.
उनको तो हमारे रोल नंबर भी याद होंगे, I'm sure.
हाँ जी, बिल्कुल बिल्कुल.
मियां साहब, अस्सलाम वालेकुम.
मियां साहब आपका माइक म्यूट है सर. जावेद साहब is sending you his greetings.
अस्सलाम वालेकुम.
मियां साहब आपको आवाज आ रही है सर? I think probably he
म्यूट है वो, स्पीकर ऑफ है.
माइक म्यूट है और उनका स्पीकर तो ठीक है, इज कनेक्टेड, लेकिन why can't he listen to you? जी मियां साहब, आपको आवाज आ रही है मेरी? मियां साहब आप म्यूट हैं, आप म्यूट हैं, अनम्यूट करें उसको.
अनम्यूट.
जी मियां साहब, अब आपको आवाज आ रही है मेरी?
आ रही है जी, बिल्कुल आ रही है.
जी
जी, अस्सलाम वालेकुम मियां साहब.
जावेद मलिक साहब आपको सलाम कर रहे थे, तो शायद आपको आवाज भी सुनने जा रही थी. ये 5:02 हो गए हैं. इंशाल्लाह जी एक दो और पार्टिसिपेंट्स आ गए तो फिर इंशाल्लाह बिल्कुल स्टार्ट करेंगे.
इंशाल्लाह.
जिन लोगों ने अपना वेब कैम नहीं ऑन किया वो प्लीज आ जाए, वेब कैम ऑन कर लें. मैं 1-1.5 मिनट में 1-2 मिनट में इंशाल्लाह स्टार्ट करूंगा जो रजिस्टर्ड है सीपीडी के लिए.
ठीक है, फोन दबा दो जी. पानी चाहिए आपको? अभी चलिए मैं मंगवा देता हूँ।
That's fine.
रिजवान को नहीं फोन किया रिजवान भट्टी साहब को भी रिमाइंड Bismillahirrahmanirrahim. In the name of Allah, the most gracious and the most merciful. Ladies and gentlemen, Assalamu alaikum and good evening from Pakistan Society of Civil Engineers based in Lahore, Pakistan. A very warm welcome to all the participants who have joined us on Zoom and on Facebook. This is lecture number 46, organized under the auspices of Pakistan Society of Civil Engineers. Before I talk about today's lecture, I want to make an important announcement. In addition to the technical lectures that PSCE presents every month, I am happy to inform you that PSCE has launched another program, which is again a technical in nature. It's a panel discussion on the issues that industry in Pakistan related to civil engineering is facing. The first program of the new series has already been recorded on the topic of tall buildings. The program recorded is currently in the process of editing. Inshallah, within next week, it will be uploaded on our YouTube channel for everyone to view. Please do watch that program and do not forget to write your comments, because your comments would be a valuable learning source for us to improve the program further. Now coming back to today's lecture. Today's topic is good practices in structural engineering. Our guest speakers are Engineer Bashir Malik and Dr. Asif Wahidi. Before I introduce the speakers to you, it is my duty and responsibility to apprise you of the rules of this webinar. Registered participants for CPD points have to appear live on webcam. However, for ladies, there is an exception. If they wish, they can cover their face while appearing live on webcam. During the lecture, microphone of all the participants except that of speaker shall remain in mute position. As a routine, you people are already aware that we have a question answer session at the end of the lecture for 20 minutes. The speaker is more comfortable, both the speakers are more comfortable if the questions are asked during the question answer session. But if there is any important question which I feel is necessary to be asked during the lecture, inshallah, I will intervene and I will request the speaker to answer that question. During the question answer session, you will have the option to ask the question through your microphone, but during the lecture, you can only type your question in the chat box. And Facebook participants have only one option. They got to type their questions in the chat box only. Using microphone facility is not available at this time. Now, the introduction of our guest speakers. Our first guest speaker is Javed Malik. Malik Saab is the Director of Program Management for Jacobs Engineering Group in their Houston office. He is a licensed professional and structural engineer. He has worked on the design of several high-rise buildings, parking garages, industrial and petrochemical facilities, water and wastewater treatment plants, and advanced electronics manufacturing facilities. Some interesting projects that he has currently working include the design of a new airport terminal, a new semiconductor manufacturing facility, and a new electric vehicle manufacturing facility. One of his many specialties is the design of structures for blast overpressures. I think the first lecture 2 years or 3 years earlier he gave from PSCE forum was on blast overpressures. Malik Saab is a member of ACI Technical Committee 315 and has published several papers in international journals. Now coming to Dr. Asif Wahidi. Dr. Wahidi has retired as a principal and engineering manager for Walter P. Moore and Associates, a premier structural engineering company. Dr. Wahidi earned his doctorate from University of Texas at Austin. His role at Walter P. Moore included the design reviews and mentoring young engineers. Dr. Wahidi has extensive experience at the design of various kinds of structures, including high-rise buildings and long-span structures that include retractable stadium roofs. He is very well versed in both steel and concrete design and has published several technical papers on the design of buildings. So, gentlemen, this was a very brief introduction of both of our guest speakers. Now, sir, Malik Saab, the floor is yours. Please continue with your lecture. Thank you. Huh?
Can you see my screen? Can you see my screen?
Yes, sir. Go ahead, please. Everything is okay.
Okay. Bismillah ar-Rahman ar-Rahim. Alhamdulillah Rabbil Alameen. As-salatu was-salamu ala Sayyidina Muhammadin wa alihi wa sahbihi ajma'in. Thank you for inviting us. Today's topic is good practices in structural engineering. And I think we have already gone through the introduction, so I will skip this slide. So the agenda for today's presentation is as follows. We'll start with a safety moment, which is a typical practice in all the meetings that we have in US. Then we will just briefly discuss what constitutes good engineering practices. And that includes the quest for excellence. We'll talk about that. Structural news and information, new technology and software, questions and answers. So half of your good practice is based on the knowledge that what's going around and what's happening in the structural world, what other people are doing and using. So we will try to address these today. So we'll start with the safety moment. As we are aware that in Pakistan, there are these devastating floods, which have affected 1/3 country and killed a lot of people. There's a political instability in Pakistan. The inflation is peaking, the load shedding is going on. So people are frustrated, they're depressed, they're angry. But we need to remember that anger is just one letter short of word danger, because it can lead to dangerous actions on the part of that person who is angry. And I will just give you these stats here that angry people are more likely to sustain serious injuries, not only at work, but every place. And I will not go through these stats, but as you can see, most of the patients who were injured were angry or irritable before they got, before that accident occurred. So we have to see, I mean, what we can do to take care of the anger. Just to share you with a recent story in our Houston area, one of our Imam Masjid, his two sisters were driving and they were killed by an angry driver because somebody must have cut off the other person or whatever. I don't know the details, but because of his anger, this person got out of the car and killed two young girls. So we need to avoid those situations. So what we can do, or what can we do to basically avoid being angry at work? I just use the word at work because here in US, there are some angry people who just, if they are laid off or whatever happens to them, they just pick up the gun and start shooting, whether it's school, whether it's work, or anywhere else. So the slide is tailored towards the anger at work, how to avoid that. So we need to basically determine the reason for the anger and try to remain calm. We should not react immediately or overthink. We need to assess the situation and see what we can do. We need to communicate. Most of the anger occurs because we are not communicating properly. Either we are not listening or the other person is not listening. So if we can communicate better, then that can hopefully take care of some of the issues. The next thing is, if you cannot get away from an angry situation, then you can remove yourself. You can move out. If there's a person which is bothering you, he's continuously attacking you, just avoid that person, because he will make you angry and you will react in a bad way also. You can take a walk, you can take a break, do things that make you happy, and look for the positives. Always look at the glass which is half full and not half empty. And also, don't sweat the small stuff. Don't get mad on small things which are not going to bother you the next day. So there is no reason for you to be angry about those today. So that were my 2 cents on those. So now the next thing is, we come to our topic: what are the good engineering practices, or what are the good structural engineering practices? And why am I calling these good? Why are these not the best engineering practices? And again, we do not use the word best because what we may think best today may change tomorrow. So as practice which is best today may not be the best tomorrow. Also, the definition of best changes from person to person. And if we think that what we are doing is the best, then the quest for excellence goes away. You don't want to improve on the things. You think that they are the best things anyhow. And the reason why we chose this topic, because we work with the engineers from all over the world. I personally work with people from all over the country. In one particular day, I may be interacting with people from all over the US cities: Poland, Philippines, England, Canada, India, Australia, Dubai, and many other countries. And all of these young engineers that I work with, they bring their own flavor and work ethics to the table. So, and young engineers in Pakistan are basically used to the local conditions and practices. So this will just give you them an insight as to what we see in other people. and what are the good things to do to basically make your practice the best practice. So basic gist of that thing is we need to do things right. Always act with integrity, taking responsibility for our work, caring for people, and staying focused on safety and sustainability. And challenge the accepted. Know that to create a better future, we must ask the difficult questions, always stay curious, and do not be afraid to try new things. One of the things which we hear from people here when we go to the job site, oh, we have always done it like that. And that to me is unacceptable. I never buy that. I tell them that they have to change, and whatever is expected from them, they need to do that, rather than telling us that what they're doing or what they've always been doing is the best thing. And the next thing is we need to aim always higher. Do not settle. Always look beyond to raise the bar and deliver with excellence. Be committed to your clients by bringing innovative solutions that lead to profitable growth and shared success. So the gist of a good engineering practice is the good ethics. And I will come into more details on what the good ethics are. Competency, good ethics alone are not enough. A person who is practicing must be competent enough. He should know what he is doing. And then competency even is not enough if you do not keep yourself up to date with the state of art knowledge. You need to at least be aware of what is around, what's going on in the structural world or in the world in general, what other people are doing. So that is very important. And then the use of modern tools and technology. The world is advancing. I'm working on some projects right now where the deliverable is not even the drawings. We are so much used to these paper drawings and documents. On that project, the deliverable is not drawings, it is the Revit models. So you deliver these Revit models to the clients and they take it from there. Of course, there are these typical details and notes. Those are still in the PDF form, but paper is gradually going away. So we need to be aware of what are these modern tools and technology. If somebody is not well versed in Revit nowadays, then he's losing the battle already. So we need to be up to date with these tools and technologies if we want to compete with the rest of the world. And then also, as I said, the quest for excellence should always be there. We cannot remain stagnant. What we have done today, we always need to improve that. Even if we are doing a repeat project, we need to make sure that we look at the ways to improve even our own product. That's why you get different versions of iPhone 9, 10, 11, 12, because there's a continuous improvement. And we need to bring that same excellence or the quest of excellence in our practice also. So I will start with the ethics. And ethics are defined as the discipline dealing with what is good and bad and with moral duty and obligation. And here is another definition of ethics. I will not read it, but bottom line is that I will just give you a summary of that. What are the good ethics? Good ethics are honesty and truthfulness and trustworthiness. As we call Sadiq and Amin in Pakistan, those are the core of any good ethics. We need to be honest and truthful. In US, I can tell you that if you speak a lie and you are caught on the camera, or you are caught by the court or the police that you have said you have told a lie, then you are basically doomed. So that is very, very important. Transparency. Whatever we do, we need to be transparent in our dealings. There should not be any hidden dealings or anything like that. Accountability. We need to be accountable for our design and be responsible for it. We cannot put a blame on somebody else if something goes wrong. Oh, he told me this, he told me that. And the young engineers that I see here in this country all over the world, I mean, they're very transparent in their calculations. If they make a mistake, they admit it. They're accountable. If you tell them, I review a lot of projects from all over the world, basically. And if there is something wrong, people take the responsibility. They say that, okay, we made this mistake and we will correct it. There is no excuses that are given. So that is part of the good engineering practice and the good ethics. And confidentiality. Confidentiality is very important. A lot of projects that we are doing nowadays are advanced manufacturing facility projects. Some of these are electronic vehicle facilities, the state-of-the-art facilities, basically. So the client is going to build something very confidential, maybe the next version of the iPhone, or maybe the next chip or something. So if the client does not want us to discuss his project with somebody else, we need to do that. Here in US, we have to basically sign papers just to make sure that we tell the client in writing that we are going to keep his project confidential. And obedience to law. Of course, that is the gist of any society, obedience to law. It's very important. Laws means that we need to follow the building codes. Also, the international laws, local laws, we need to follow. One of the course which I recently took, and we are supposed to take this course after every 2 months, was on international bribery. We are not supposed to bribe anybody to get a project. We cannot even take the government officials out for dinner because the thought process there is that you're going to persuade them to give you their next job. So we cannot take them out for dinner. These are some of the core ethics. Just imagine if these ethics are there in US. Pakistan is an Islamic country, and just following the guidance of the Prophet ﷺ alone should give us more than ethics, more than what I've shown on this slide. So those are basically the core of any good engineering practice. And anybody who practices engineering in Texas, just like in Pakistan, basically has to get licensed as a structural engineer. Without that license, you cannot practice the engineering, because the job of a licensed engineer is to protect the public health, safety, and welfare. And also, state can evaluate people and determine which people are competent, which people are good for the practice of engineering. And here are some more details of the Engineering Practice Act. I just copied it. You will get a PDF copy of this presentation, so you can read that. But the gist of that is, the key points are basically that any licensed engineer is responsible for his design since he is interested with the health, life, and safety of public. And the sealed contract documents must be prepared under the direct supervision of the design professional. You cannot just give your project to somebody else and say, okay, you do it and I will sign and seal it. That is totally illegal. If it is found that you did it, then your license is revoked or may be revoked. Only a person designated as a licensed professional engineer can sign or seal the contract documents. Every month I get a letter from the state board, and I am registered in several states, more than 20, I believe. So I get these letters from all those states telling us that how many people's licenses were suspended or what actions were taken. And some of these things you may think are very, very minor, but people are supposed to be totally honest and work with integrity. So these are the very first thing of a good engineering practice, as I said, is the good ethics. So with that, we'll move on to the next part of that, which is the quest for excellence. As I said, good ethics alone are good, but engineering practice, if you want to do, then you have to shoot for the excellence. And here is Dr. Asif Wahidi, who is going to, he was an engineering manager for almost, I don't know how many years. So he will give you some tips to the young engineers also as to what to look for and what to do. So without any further delay, I will hand it over to him.
Thank you, Javed. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. I'll start with this topic, and which is quest for excellence. And we start with the question, what is quest for excellence? I wanted to sum it up in few words, and quest of excellence to me seems like we have to strive every day to do better than what we did yesterday. This is something which Javed also mentioned. And this is a continuous struggle throughout our life. And in everything we do, it's not only engineering, everything, dealing with people, following the law, working at the office, not getting angry, and things like that. Everything is quest for excellence. When applying to engineering projects, we can make them better by developing specifications, by following, I said, best practice here, but should be good practices during design and construction. Conduct quality control at every step of the way. Don't wait till the end of the project to come and put in quality in there, because that may become difficult. Also, throughout this process, we have to use the latest knowledge and also learn from our previous mistakes and not do what we did on the previous project. Remember, we have to do better than yesterday. Specifications. A lot of us don't pay too much attention to these specifications, but specifications are important. Specifications should cover everything which we want the contractor to do. A good contractor may do everything without any instructions, but sometimes the contractors bid low to get the job, and then they want to make up for their losses, so they are cutting every corner. Even if they know how to do good, they're cutting corners to make profit or to cut their losses. So having said that, we move on. The specifications have to be complete, even starting with preparation of construction. No site is ready for construction. You can't go in there and just start putting your foundations without doing anything. You have to clean up the site, and remove the loose stuff, the shrubs, bushes, grass, everything. And remember, the spec should also tell the contractor to clean up the site after that. I'm on the committee for our mosque, and one of our contractors left the site dirty, all the bushes, everything, and garbage was there. And when we asked them to pick it up, they wanted to charge extra. So this is what the contractors do to make more profit or cut their losses. So to keep the contractors honest, tied to the contract, avoid having extra payments, requests and lawsuits and stuff like that. Everything should be in the specifications. Moving along, of course, the specifications should also include excavation, cutting, filling, and grading. Compaction also should be included, including, we don't have to specify everything exactly what to do. We can refer to the standards which are already there. Like for compaction, we have got ASTM standards, ASTM D698, and there's the other one also, I don't remember the number for that. We need to specify which standard to use, how much should be the maximum compacted density, and the compaction should be done within few percentage of the optimum moisture content. Digging or drilling for the foundations is very important. Foundations have a few things inherently very important that we need. Number one, the base of the foundation where the load is going to bear, that should be on undisturbed soil. And we should tell the contractor to give the opportunity to the geotechnical engineer to also come in and verify the soil capacity by observation and conducting on-site penetration tests and stuff like that, to make sure that the recommendations they gave us in the beginning for design of foundations are still valid. For footings, the contractor should not be digging it with big equipment and do it quickly and leave the bearing surface disturbed. For drill piers, they should be neatly drilled. Bells of the piers should have the required support so that they don't cave in. The drill piers should be drilled just before we are ready to concrete. The belt piers should not be left open overnight because caving could occur or rainwater could get in. So the concrete should be poured immediately after that. All this should be in the specifications. Otherwise, the contractor may not be doing it and you cannot enforce it. They may ask for extra money and so on and so forth. Any material used on the site, including making materials of getting materials for concrete, coarse aggregate, fine aggregate, all the specifications should be for them, for everything that is needed on the site, including procurement of the materials. For coarse and fine aggregates, we may want to use certain areas for excavation to get good aggregates. For cement, we have to specify what type of cement, and also we may pre-approve certain plants to where to get the cement from, and also for precast elements and stuff like that. Some plants may not have done a good job on previous projects. Remember, we learn from our mistakes, so we should ask in our specifications if some are not good, we don't pre-approve them, and we pre-approve those who have done a good job. When the materials arrive at the site, that's not the end of it. We just don't use them just like that. We need to check the quality by inspecting them and also testing them. Like, let's say the reinforcing for the concrete, when it comes, it should come with mill test reports. We should check the grade of the steel and also that it meets the required strength. And nowadays, as we see the effects of climate change, more and more standards are being developed to use recyclable material and low carbon footprint materials to be environment friendly in our construction. Some of the things which we have been doing in the past is using less cement on our projects by replacing it with fly ash and blast furnace slag and stuff. And also there are requirements for obtaining materials. In US, you get credit for getting material for construction from within 500 miles of your construction site, and so on and so forth. This area of knowledge is developing very fast. We should keep abreast of it. We should learn from the latest knowledge and apply that on our every project. Then safety of construction during construction is important. That should also be stressed in the specifications. Good contractors will always follow good practices, but we have to make sure that even the ones which are not so good should do the job correctly. Special instructions should be there in the specifications for storing materials on site and stacking them. The contractor should not stack too much material on slabs and structures which may exceed the capacity of the structure during the time of the construction or may cause cracking, deflection. Also, stacking material on ground on site is not good. The material should be elevated from the ground and protected from rain and stuff like that. All slopes that the contractor does for excavation for construction or temporarily to get the work done should be safe enough. No unstable slopes. Workers have been buried in the soil. They got injured or killed at times when the excavations failed. Contractors should provide safety for workers at every stage of the project. During concrete pours should provide and other activities. And also, safety should be provided during concrete pours and other activities. They should provide secured ladders when ladder access is needed. They should have people working in groups of 2 or more and avoid having people working alone in isolated areas. In case there is an injury, there should be other people around to help immediately. Fall protection is very important for people working on elevated levels at the edge of the slabs, roofs. Their workers are susceptible to falling over. All workers working on elevated levels should wear safety harnesses, which should be tied back to secured tiebacks to the structure. Inspection. Now, I'm not talking about inspection itself. The specifications should require that inspections be done. It should require the inspectors are chosen by the design consultants, and it should also direct the inspectors to ensure every part of the specifications are done. They should include what parts have to be inspected and when, and make sure that inspection is done at every stage. After the specifications are done, we move into the design and construction phase. Here also, we need to continue the quest for excellence. One of the first things we do is make a computer model and analyze. And one of the things that we think about on every project, and we should, is loads. We should consider all loads that could affect the safety or serviceability of the structure that we are doing, including gravity loads, which are dead loads, superimposed dead loads, and live loads. Dead loads can be estimated very easily based on the density of the materials and the volume of the materials used in the structure and finishes. Superimposed dead loads and live loads are obtained from codes. They are based on a statistical analysis of load, which is confirmed in existing structures randomly. There are, believe it or not, some people do random inspection of loads. They go in and observe the load and note down the load at certain instances for every occupancy. And then using statistical analysis, we confirm that the loads given in the codes are correct. If not, they are revised. Code loads are given to give you the safe intensity for design of every member. Large members like columns or girders, columns especially supporting many levels and large areas, could have loads constant. Only the high intensity of load may be occurring in small areas, but the average load intensity may be much smaller over the whole area supported by the girder or the column. For this reason, codes allow us to use load reduction. We should use live load reductions and even partition load reductions when permitted to economize on the structures. Remember, using less concrete, less cement is environment friendly. And also we save money, which we can use in places where it is more important. So we should use load reduction. Load reduction should be according to the rules presented in the code. Continuing on the loads, next load is lateral earth pressure. Lateral earth pressure is based on soil parameters. Soil parameters can be found in textbooks, but we should not be using those. Textbooks give us realistic soil parameters. We should use the worst case parameters and use a geotechnical engineer who should do a soil investigation and give us better parameters to be used on the project. And the picture shown here shows you active pressure, soil, and passive pressure due to the soil. We should also add to it pressure due to underground water table, if that may exist. Structures have failed because of not considering water table effects. I had about 20 years ago or 18 years ago, as I was involved in investigation of a failure of a large underground pump station. And the engineer designed for the soil pressure. Actually, his design was not up to standards. That was one of the problems, but the structure would not have failed even with that. But what happened, there were heavy rains one day and the water table rose. And actually the walls of the pump stations failed. The walls were 2 feet or 2'6" thick or something like that, or 3 feet thick, huge, thick walls, reinforced, but they collapsed, they failed, and water filled into the pumps. So this type of things can happen if we don't watch for all the loads. So we can talk about the next type of loads, hydrostatic loads, and floods are on everybody's mind. Here, all our us, Javed, me, and you all in Pakistan, flood loads have to be considered, hydrostatic loads have to be considered. Both these loads, lateral loads and hydrostatic loads and flood loads, they should be considered with the maximum intensity. But remember, for some cases, the worst intensity of the structure of the load may not be the worst for the structure. For example, for an empty water tank, and also I gave you the example of the underground water pump. The case when the water tank is empty and also when the water pumping station was dry inside, that was the worst case. So we need to consider also when these loads are not absent. So when these loads are not present. So case of underground water tank, that's the case. For case of wind loads and earthquake loads, which may act in the opposite direction of earth pressure or hydrostatic pressure, the worst case is when these loads are not present. Next load case, you guessed it, I already started talking about wind and earthquake, environmental loads. Wind loads are obtained from codes. Codes present and do statistical analysis based on wind speed observations made at different locations. These statistical analysis give us the worst loads which can be expected for these storms of category that we are designing for. And the category of storm that we design for depends upon the risk category of the structure. Higher the risk category, higher the design wind speed. Wind load, usually in a lot of codes these days have a load factor of 1. So we should make sure that we are using wind loads which are using wind speeds which will result in loads with load factor 1. For serviceability conditions, for deflections, wind vibrations, and everything, we use lesser loads which can occur more frequently on the structure. Next, we move on to the earthquake loads. Earthquake loads like wind loads are obtained from codes, which again are based on a statistical analysis of data obtained from the sites. In the United States Geological Survey compiles the data and publishes the data, which we use to determine the seismic parameters for the design for every site. Once again, a lot of things like risk category, the ductility put in the structure, and a lot of other things go in to actually determine the loads. I'm not going to get into this. Once again, load factor for earthquakes and load combinations in 1, and that's what we use for the strength design. Those loads are, when calculating the serviceability conditions, the serviceability conditions for earthquake are based on the risk category or the occupancy of the structure and how soon you want your structure to be serviceable. Some structures like hospitals and emergency structures for like firefighting and other structures are required to be operable immediately after the earthquake. Other structures need to be operable soon after the earthquake. Some maybe later on. So depending upon how soon the structure has to be operable, or the owner may want special requirement to keep his manufacturing facility or something going along. So that determines how much earthquake movement and damage we permit for serviceability conditions. Next, we move on to blast conditions. Javed is an expert of blast. I'm not an expert, but I've done a few buildings. And the picture here shows the Alfred P. Murrah Federal Building in Oklahoma City. This is after an explosion of a truck full of an ammonium nitrate fertilizer. The truck, which is full of fertilizer, exploded, and this is what it caused to the building. The building had a transfer girder at the second or third floor. This girder carried several columns. The girder failed due to the explosions, and the column supporting it also failed. This brought down all the columns which were supported on the transfer girder and a few columns nearby, resulting into progressive collapse, which were much bigger than the initial damage, with the immediate damage caused by the explosion. We are required to design federal buildings in the United States to prevent this type of failure, which is classified as progressive failure, where much larger damage occurs than that could be expected from the amount of explosives being used. All structures, fortunately, are not required to be designed for blast loads. Only those are required to be designed which have a security concern, like federal buildings, and some owners may have security concerns and stuff. Other facilities like petrochemical plants and plants manufacturing explosives or ammunitions and areas around them need to be designed for blast. Tsunami loads are becoming more and more common in codes. There has been a lot of literature that has been developed, a lot of knowledge gain after the 2004 earthquake in Banda Aceh in Indonesia and Tohoku earthquake in Japan in 2011. Now, this area is still a lot of research is being developed, codes are getting updated, standards are developed. We need to keep learning, keep abreast of the new requirements coming in and design, and also ascertain if we are designing any structure on coastal areas, we should ascertain that if there is a possibility of a tsunami and look at the codes. If they require for tsunami load, we design for it. Construction loads are important. In typical structure, usually we don't design for construction loads, but many structures, construction loads could actually be heavier than service loads. Worst design conditions may occur when the load is on partial span of the structure, or the structure itself or some element may be partially built. We need to provide special instructions to the contractor on contract documents if any special sequence or procedure has to be followed during the construction to keep the structure safe at all stages. We should also include instructions to provide additional supports if needed, or special force work needed during construction. Special loads. There could be a lot of loads. I listed just a few, starting with warehouses loaded with heavy storage loads. Even the loads may be on slab on ground. We need to have special design considerations for them. Loads for machinery and movable equipment, which requires strict structural tolerances and strict deflections, should require special design considerations. Extreme temperature loads should be considered in freezers and boiler rooms. I've learned from experience that in freezers, it's especially important to provide a thick slab at the bottom or provide additional insulation to prevent damage from frost heave. Also, additional insulation can give us economy in energy consumption. Creep shrinkage temperature effects are important. Normally, these occur on every structure. Normally, smaller structures don't have to be designed for these, but large structures, warehouses, distribution centers, we need to provide expansion joints. Analysis of creep shrinkage temperature can help us in sizing the expansion joints and determining where and how many joints to provide. Creep, shrinkage, and shortening analysis are also very important in tall buildings, where the columns in the exterior and the columns in the interior of the building may shorten differentially due to creep, shrinkage, or just elastic shortening. We need to conduct an analysis, make adjustment to the lengths of the vertical load supporting elements to make sure that our floors end up leveled at upper levels of the structure. Next is vibration check. This is itself is a big topic. I'm not going to get into the details. Vibrations can be caused by human activity such as walking, dancing, aerobics, and other activities. The structures, the picture shown here shows you response of the structure to fans who are cheering for their favorite team in a stadium. These are simulated responses. Structures have to be analyzed for anticipated vibrations. Other vibrations can be caused by vehicular traffic or machinery. These affect occupation comfort of the occupants, and also these could affect the operation of vibration sensitive equipments. Rather than getting into much more detail on this subject, I just want to caution for us engineers, we have to be cognizant when to perform vibration analysis. Otherwise, lack of recognizing vibrations have caused a lot of embarrassment even to the best of engineers. Sometimes vibrations have caused even structural failures. One example comes to my mind, the London footbridge, the London Centennial footbridge. And that bridge was opened in 2000 and it has to be closed shortly after that because of serious vibration problems due to lateral vibration of the bridge. It took almost 2 years and 18.2 pounds for the engineers to design and provide 89 dampers, like shock absorbers or dampers, to solve the vibration problem. And the bridge was reopened in 2002. We can see from this example, if we do not pay attention to vibrations, the fix could be very costly and time consuming, and not to mention embarrassing. From special loads, we move to special load cases. For continuous structures, the worst case is not loading all the spans with the maximum load. Often, the worst moments and shears are caused by pattern loads as shown in the pictures. Similarly, for structures like domes, arches, and even trusses, partial loads or point loads could cause stress reversals or maximum stresses more than what you expect under full design loads. So partial loads should be considered. Point loads, which may be even less than full superimposed load, could cause more stresses in a dome or arch, and even stress reversals in trusses. Now we're done with the loads. Yeah, engineers have the habit of just doing the analysis and getting on the drawing, or as Javed said, maybe completing the Revit model and sending it out. You are not ready for that. Good engineer always checks the results. Once you get the analysis done, make sure the results are valid. There is no mistake. So do deflection, check the deflected shape, check the range of displacements, verify support locations and constraints, check equilibrium, run approximate calculations to see displacements and stresses in your computer analysis seem reasonable. We are going to get into each of these deflected shape. This is the easiest and most valuable information. Look at the deflected shape and the magnitude of deflection. Important things to note here is don't use the worst possible and the most complex load combination to do this. Keep it simple. Okay, like Honda says, keep it simple. Keeping it simple helps you see what's going on. So use vertical loads only, cases with vertical loads only, lateral load cases only, special load cases individually, no load combinations. Then you, with your intuition, you can tell whether the deflected shapes looks right or wrong. If it doesn't look right, then there could be a mistake in the loading, mistake in support constraints. There may be missing supports, too many supports, or wrong constraints, maybe fixed supports is represented as hinge support or roller support or vice versa, things like that. What if the deflection shape looks all right? You should also pay attention to the magnitude of the deflection. If the magnitude of the displacement is wrong, then first culprit is definitely member properties. Check the member properties. There's a mistake in member size, material selection, property modifiers, which we use for modeling cracking of the materials and other stuff. Those could be wrong. These are the most common factors, but then the load could be wrong. And load magnitude could be wrong, or some load could be applied in opposite direction and stuff like that. This does happen also. I've had this happen. Then when we are auto-generating loads, our computers are very smart these days. We can generate the loads automatically from wind and earthquake, but sometimes the auto generation may not work fine. One example I want to relate here, this is an example related to aeronautics, to an airplane. This happened in Canada, and it almost caused a disaster. There was a flight in Canada about 600, 700 miles range. The people fueling the aircraft calculated the weight of fuel needed in kilograms. And when they filled in the tanks, they loaded based on the same number of pounds. So guess what? And the plane ran out of fuel halfway to its destination. The pilots scrambled. They looked for landing strips nearby, landed on a small strip, which was abandoned. And actually on that strip, that was converted into a strip for drag racing. People were bringing in their cars, practicing for racing. It was Saturday, it just happened to be Saturday. The plane landed over there. Everybody was very fortunate. Nobody died or got seriously injured, but this could have been disaster. Similar things could happen. We, in the United States, we still work using pounds. But again, we get projects where stuff has to be noted in meters, kilograms, and stuff. This can happen to us when mixing units and stuff like that. So be careful with the loads. I cannot stress this more often. Next, check the equilibriums. Very intuitive. Then we go along, and these equations which I'm showing are very simple. You're saying, why is he showing? All the sigma fx, y, z, mx, my, mz, these are always zero. They're always zero because our software takes care of it. This is not what I mean. When I say check some of the applied loads and check whether they are equal to the reactions, you calculate your applied loads by hand. Again, use vertical loads only or lateral loads only, not load combinations to keep things simple. If you've got a live load case, 100 PS of live load on every floor, you just take the area of the floors, multiply by 100, you know the total load, see the total reaction in your computer. If it doesn't match, there's a mistake. Auto generation of loads, we have had problems with that on many structures. Auto generated saves a lot of time in making a model and running it for wind loads, earthquake loads. But sometimes the software does not apply the load correctly. Sometimes the members on which you are applying the load, you forget to select one member, or you select a lot of extra members which you don't intend to, and the load is wrong. One time I remember the example, our software was not calculating wind loads on the parapet wall. And we had a 3-story structure or something, the parapet walls were significant. So we auto-calculated the wind load using the software, and the engineer manually input the load on the parapet. We knew the base shear. When we ran this structure, we looked at some of the loads, some of the reactions. It was very small. Accidentally, our engineer put the wind load with the wrong sign. The wind load on the parapet was acting opposite to the auto-generated loads. These things happen. So in short, yeah, calculate the applied loads and use the total sum of the load on the building, like live loads, wind loads, base shear, earthquake base shears, and compare with them total reactions. What if they don't match? Then again, some loads may be missing, unwanted loads may be there, few loads may be applied in opposite direction. And unintentionally, this has happened to me also, unintentionally I made a model and somehow I don't know how, the software generated a support somewhere maybe hundreds of feet away, which was not even showing on the model. And when I looked at I selected my supports and looked at some of the reactions, it did not match. So these things happen, and sometimes unintentionally, some loads go somewhere where we don't want them to do. After the loads are checked, finalize your design. Make sure all the forces acting on all members are less than those allowed by the codes. Serviceability requirements, displacement, deflections are less than those permitted to prevent structural damage, or they are based on safe limits for operation of equipment, etc. Vibration limits, again, are in the safe limits for its occupations and are safe for the operation of supported materials. If there is any additional criteria on a special structure, that should also be finalized. If above checks are not satisfied, you have to redesign and then make sure everything works before you issue the drawing. And again, before issuing the drawings, do quality control. Quality control should not be done only at the end of the project, but throughout the projects. Appoint quality control team in the beginning, keep them informed about the design criteria, and if you make any changes to it, have quality checks during the process of the design at 30% complete, 60% complete, final, and so on. During construction, we need to observe what's going on, have the contractors submit a lot of stuff so that we can monitor everything is being done according to our contract documents, shop drawings, material test reports, weld inspection reports, stressing reports, for pre-stress members, any other reports that may be needed due to the special nature of projects and stuff. Anything of this which does not meet the design document, we should reject it and have the contractor corrected before we move on. Then we move to site inspections. A last measure to make sure everything is going right is site inspections. We should appoint the inspectors. We should direct them where to inspect and when to inspect, and ask them to report everything in written reports regularly. If anything is found which is not safe or the tests are not meeting the requirement, they should report to the design team immediately. All unacceptable conditions should be corrected immediately and re-inspected till everything is found satisfactory. I'm going to stop here and hand it over to Javed. Sorry, Javed, that took a lot of more extra time, and we move on.
Thank you, Dr. Wahidi. while he was talking, before I start with this quality control review process, while he was talking, I realized that there's an important slide which we could have added was knowing what materials to use. We are used to certain materials and we use them, but we need to, as an engineer, if we want to shoot for the excellence, then we need to know what is out there that is available. One of the things that is has lately become available is the high grade rebars. We were used to these grade 60 rebars when I was young, when Professor Ziauddin Mia were teaching us, we used to use 36 grade or 40 grade rebars. Then in US, we went to 60 grade rebars. Now, grade 80 and 100 rebars, grade 100 rebars are available, and we should use them. I was doing a project last year of a big electric vehicle manufacturing facility. There were long spans, big loads, and I proposed that I was the engineer of record for part of that. And I proposed that we use grade 80 rebars. And the contractor was resistant. He did not want to use that because he's used to those grade 60 rebars. So we did a price survey and found out that the grade 80 rebars are only 7% more expensive than grade 60 rebars. But the increase in strength that you get is 8/6, which is 33%. So you're getting 33% more bars for only 33% less rebars for only a 7% increase in the premium. So finally, we were able to sell the contractor or convince the contractor, and he used those. So what we did was we used all the number 8 or higher rebars. We used these grade 80 rebars, and anything that was smaller than a number 8 or 1 inch diameter bar, we used the regular grade 60 rebars. So that is one thing which we need to be aware of. These high strength rebars can save us a lot of money in transfer girders, in high-rise columns, in deep beams, in thick mats, where you need all that steel for your bending or creep and shrinkage or whatever. So these higher grade rebars can save you a lot of money. So you should be the first one to bring those ideas to the owner and the contractor. Also in structural steel, we used to have grade 36 steel, ASTM A36 was pretty common. Then when I started practicing, grade 50 came, and it was only 7% more expensive. Now they are the same price, so we started using those, the higher grade steel for our beams. Now grade 65 steel is also available. And for columns of a steel building, we need to start considering that. Also, we need to make sure that we are aware of the new technology. In Pakistan, there's very little post-tensioning work being done. I know an Indian friend who was with me in US. He was just practicing, and he worked on a post-tension project where you apply pre-stressing after the concrete is built. And he realized that it was not there in India. So he became the pioneer in India for that work. And now he's a very, very successful businessman, a good engineer who kept his eyes open on the new opportunities. For all those young engineers who are listening, if you just want to take another upper notch, you need to start looking at what other people are not doing that you can do, and you can fill the market void, or you can be the first person. So in Pakistan, we are still using a lot of concrete construction. There's not much pre-engineered metal buildings that are used, which are pretty common in the US. They're very economical and cheap. So we need to start looking at those kind of things. Also, fiber wrap, which I will talk briefly. That's another important thing, which is a new technology. So we need to jump on these new technologies and see what we can do or what we can bring to the table. So we should be the first one. Not only for Pakistan, all these countries which are around us, we can just, if we master that technology or that material, then we can do our practice in those countries also. So that is something which you need to look at. Also on the software front, you need to be aware of what the softwares are, and I will talk briefly towards the end of my slides what are the latest softwares available, but you need to be aware of what these things can do. Yesterday, I was working on the airport project. We released 60% steel. And so I was asking the engineers who were working on that what is the total tonnage of the steel and what is the pounds per square foot. And one of the young engineers opened the Revit model, because everything is model. All these schedules that we make on Revit are smart schedule. So if you change something in schedule, it automatically changes it on the drawings also. So with these smart schedule, within the next 30 minutes, he was able to tell me that we use, let's say, 4,000 tons of steel on that project. Or it was pretty exact, I mean. So we need to be aware of what this technology is, rather than giving it to a person who goes to the drawings and start calculating the steel tonnages. You can just quickly use these tools which are at your disposal to get your answers. Now we will go through the quality control review process, which is a very important process. For any project, as Dr. Wahidi said, that we need to basically steer our project towards the quality rather than just controlling it at the end. So if you involve an independent reviewer in the beginning of the project, he can start looking at your project and give you his independent opinion. An online review is becoming very, very common now. And COVID, those 2 years of COVID has accelerated everything which is online. And the software that is very commonly used is Bluebeam software. It is just similar to Adobe. If you don't have it, I highly recommend the companies to get this software, because many people can review the same project at the same time and have their independent marks on the drawings and specifications. So the process goes like this. The design engineer adds the drawings and specifications to the Bluebeam session, and the assigned reviewer reviews the documents and makes his comments in red or blue or whatever color he chooses. Red is the most common. Then the design engineer either accepts the comments and modifies the documents or does not accept them. So if he accepts them, I mean, with one click, the change of that comment changes to green or some other color. And that way the reviewer knows that the designer has accepted that. So if there are some comments which are not accepted, so they are discussed with the reviewer to just let him know that what was the reason that the things were done that way. So once a resolution is reached, the reviewer basically makes sure that the drawings are corrected, and then he checks the corrected drawings again and verifies that his comments have been addressed, and then he signs off. So different colors are used during the review process to identify the comments, and then they are made part of the record. So this is a screenshot of a Bluebeam session that I was in. As you can see, there's a comment in red because I noticed that there was a column which was coming in the stair. So I alerted the Revit designer that his column is either jumping out of the building envelope or getting into the stairs. So he's supposed to look at that. There was another comment which I had. I wanted to show him the spread footings with solid lines, and that comment was not accepted because the designer told me that this view is taken several feet above the footing level, and there are other things also. So that's why they have hidden the footings. So with this thing, with this kind of communication, you can basically give a very, very good quality product to your clients. Now we will just have some structural news and information. And as I said, being a good engineer, you do not have to do everything. You at least have to know what's going on. And if there's an issue, which is the person who you can go to who can give you an answer for that. So here's a list of the latest codes. The latest code is the International Building Code 2021. And then we have this PSCE 722, which has just come out, which is the minimum loads and associated criteria for buildings and structures. We are still using 716, but PSCE 722 has come out. And I will briefly discuss what are the changes in that. American Concrete ACI code 31819 is there. there are very significant changes in that, and people are not, I'm reviewing a lot of design where people are not using the changes which have been made in this code, particularly for the shear design. And they're giving me the excuses that the city in which the project is located does not require IBC 2021. They are still doing it based on the previous IBC version, which deals with ACI 31814. And my response to them is that safety cannot be compromised. If we know that something has changed, then we need to basically take care of that. Then the ACI Manual of Steel Construction, we are still using the 15th edition, but the new version is coming pretty soon. The masonry code is ACI 530.113. A newer version of that is coming. And then American Welding Society D1.1, D1.8 structural supplement. That's what we are using. And there are several codes here which I have omitted, but these are just for the quick reference so that we know what's happening and what codes are out there. So 2021 building code IBC, this is how it looks. The snow maps have been modified. Secondary rain loads have been added. Special inspection requirements have been added. ACI 117 and ITG have been added by reference for concrete tolerance. Now you will question that, how do I know? And I can tell you that I have not even touched this 2021 code, so how do I know? Because in our company, we have a department who deals with this thing. So we task the young engineers basically to just go and see what's going on with the new codes. So they give a complete report to us as to what's happening. And so this is their finding, which I'm sharing with you. So bottom line is, I don't have to know everything myself, as long as I know the person who knows that, and I ask him to help me, he can help that. Now in ASC 722 minimum design loads, and this new version is out there. This is how it looks. And I have a PDF copy of that. I have not glanced through that. We are still using 716, but this is out there, and pretty soon everybody will start using it. So why not use it now? Particularly if you are doing a tornado resistant design, there are new provisions in there, which we can look at. Ground snow loads have been changed. They have become slightly higher, those drift loads. New multi-point seismic spectrum for certain soft soils has been added. There are several ACI design publications which are out there to help you. These are the companion to the ACI 31819. They help you understand what's going on, what is the reason behind the code provisions. So a good engineer should look at those. If there's any question in his mind, then he needs to look at that. ACI 1721 volume 1 is for the member design. So it contains more than 1,000 pages of detailed examples of one-way and two-way slabs, beams, diaphragms, columns, structural walls, and foundations. And then volume 2 is the special topics. So volume 2 contains examples for retaining walls, serviceability, strut and tie method, and anchoring to concrete. And these are both combined in one PDF version. And unfortunately, I just had to remove the link. I mean, on this presentation, there was one click where you could have clicked there and you could have gotten the access to those documents, but because of the copyrights, I had to remove that. ACI and 1721 volume 3 is design aids. So basically it contains the reference tables, analysis tables, sectional properties, and column interaction diagrams. Even though we have softwares now where we can put the numbers there and it can develop those interaction diagrams for us, but these are some handy tools. Then ACI 35020, which is the code requirements for environmental concrete structure. This is the first update to ACI 315 over 15 years. The previous codes were based on the service load design, and they did not recognize that the ACI has gone to an ultimate load design, or some of the provisions at least. So they have addressed that and included those load combinations in there. Then ACI MNL 320 Guide to the Code for Assessment, Repair, and Rehabilitation of existing concrete structures. That guide is out there. And finally, ACI MNL 6620, which is the ACI detailing manual, is out there. And I am glad to report to you that I am part of this particular committee and part of the team that developed this ACI detailing manual. So there are good examples in there. There are some good details there. Please, if you can, just go and take a look at those rather than reinventing the wheel on a certain issue. Just go and take a look at those details that we have developed, and you can use some of those. And of course, nothing is perfect. You can always improve on those details that are there. Now we'll talk about this ACI 38019 strut and tie model method. This chapter 23 deals with the strut and tie method. And there are 12 changes to STM or strut and tie method for discontinuity regions. So there are examples which are out there. The example could include the short beams, concrete corbels, and members with openings. Research has shown that strut and ties are weakened by diagonal tension rather than bottle-shaped behavior. So changes to strut efficiency factor and shear stress checks are there. And there are YouTube videos. There's a link here where I will send you the PDF copy, and you can click on those and listen to those or watch those videos and listen to how people are designing those strut and ties. And ACI PCI combined strut and tie method guideline for ACI 1389 is also there. And this is how it looks like. One thing which I may want to caution you based on my recent experience on the strut and tie is that sometimes people just complicate their lives. There are some simple situations and they go with this strut and tie method, which requires a lot more involvement and calculations. And there are easy and simple ways of doing things. So you don't have to always go with strut and tie. It's an option that you have for complicated situations, but there are easier ways to calculate your or design your members. The new guidelines for these tsunami loads are there and effects. It's the ACI guide to the tsunami design 716. Dr. Wahidi, you were talking about that. So there, that guide is there now. You can read the examples in there. It provides clear and authoritative explanation of PSCE 7 tsunami load requirements. And it includes the detailed examples of prototypical buildings. There are other ACI 716 design guides that are available. Seismic load guide is there. Wind load guide is there. And these basically, if you read these guides, then they will help you understand how the wind loads are calculated, and if there is a particular situation, how to apply the load requirements to that situation. Snow load requirements are there. And rain load, this guide is there. So all these design guides are available to help you. ACI wind load design for the petrochemical and other industrial facilities. The new second edition is available now. And this report is intended for use with PSCE 716. As they say in Urdu, bahut der ki meherban aate aate. We have got this ACI 7-22 now available. So this guide is still referencing to the old code, even though it just came out. So, but I mean, it's a ever-changing process. So basically the guide covers the fundamental wind engineering, general aerodynamic design consideration and methods, specifically related to the types of structures found in petrochemical facilities. It deals with the wind loads on open frame structures, alternate methods, special wind load requirements for LNG facilities, which are probably needed in Pakistan for the energy crisis. Uncertainty associated with wind loads are discussed. And there are many examples for various structure types. So you can go through this guide and it can help you. Then FEMA AP 2091, practical guide to soil structure interaction, that is available. That will help you understand where to use these requirements. Why is the soil structure interaction more important? the situations where SSI is important. So you can access that guide. It is meant for large building footprints, substantial foundation embedments, high structure to soil stiffness ratios, foundation rocking, and also it is very important, the soil structure interaction for the machinery, which is vibratory machinery, which is sitting on the ground. You have to know how will that interact with the soil, and what dynamic properties of the soil will be needed to do that analysis. And there's a good article in Structural Magazine, December 2020, you can look at that also. And here is a quick link to that. Then Simpson strong tie composite strengthening system, they have come up with their guidelines. And these composite strengthening system can be used to reinforce the existing buildings. If there's a deteriorating condition in the building, you can wrap those with these and increase the strength. If there's a more load that you want to put on a beam, you can these fiber wraps to increase it's basically an external reinforcement that you're putting on these. And you can use these. Hilti and Sika has also these things. I know Hilti has a Pakistan office also. So, and Sika may have that also. So there are a lot of things out there. If you're cutting openings in an existing building, you can use these wraps as external reinforcement to stiffen the area around the openings, whether they are floor and stuff like that. AISC Design Guide 25 second edition is out there. It deals with the frame design using non-prismatic members. So I was mentioning that there is not much pre-engineered metal buildings going on in Pakistan. This is one of those things. These buildings are very, very cheap. One of the cheapest kind of construction that you can do. So there's a guideline here in case you want to design it. It tells you how to do the analysis. It was developed in conjunction with the Metal Building Manufacturer Association. It has 400 plus pages of design examples, and it gives you the detailed procedures on how to basically analyze these kind of buildings. And it complies with AIC 360-16. Then AISC has several educational seminars, there are articles, there are recordings that are out there. So there are 30 to 60 minutes to 6 hours seminars. And most of these recordings are free to view. So this information is out there. And if you want to be excellent, you need to know what's going on. You need to spend some time on the and review these kind of videos. And this is the best application of the electronic media for those people who want PDH in US. I mean, there are opportunities to earn those through these. Then there's a steel conference which takes place every year. The next one is in Charlotte, North Carolina on April 12 to 14. There are nice lectures, seminars, presentations there. Then Applied Technology Council is not behind anybody. They are a non-profit organization. And basically they have these ATC hazard by location maps. So you can, if there is a site where you're building the building, you can click the latitude and longitude of that building and click there, and it will tell you what the wind pressures are, what the snow loads are, if there are any tornado loads. It will give you the seismic characteristics of the soils in that area. So you can get all those. For bigger structure, you may need site-specific seismic study, but most of the information is there on this by one click, basically. And there are training opportunities also. There are these seminars that you can go and watch for free on their site. Now I'll briefly talk about the software update. I think we are running up on the time, so I will just quickly glance through those. And the purpose of these last few slides is so that you know what is out there and what's going on in the software world. I have not included Revit. Of course, they keep on bringing up their latest version every year. So 2021 and 2022 are out there. So if you're using a Revit project, you have to make sure that you check with the other consultants and make sure that whatever everybody's using, you have to use that particular version. On the STAD front, I don't know how many people use STAD, but STAD keeps on adding or keeps on improving their stuff. This is the latest version that you see on the screen. What's new? Improved physical modeling workflow. Structure wizard has been added. You can now put tapered members in there so that you can do this pre-MB analysis. Analytical workflow is better, improved. ASC 716 combinations can be generated now. Chinese and Indian codes have been updated. Hopefully Pakistani code will come there, inshallah ta'ala, one of these days. And you can click there for the complete description. Release notes could be accessed there. And as I said, the PDF version that I will send you will have those links in there, those live links. STAD Foundation Advanced Connect is there. Version is this. What's new? Canadian concrete code for isolated footings, MAD foundations, and pedestals. I know that doesn't matter to you in Pakistan, but we use this seminar here in US also. So this is just tailored to be for everywhere in the world, basically, so that everybody can benefit it. Foundation punching shear has been added for the Indian code. New load generations for vertical vessels have been added. And you can click those links for the complete description. RAM structural system, which is a very, very commonly used program, that is out there. Version is, the newer version is out there. This is the latest version. And the new Simpson strong tie, they have added those special moment frames in there. Diaphragm force reports are now available. And these are some of these things which they have done. So you can click through those, through the PDF. Similarly, RAM Concept Connect is out there. Version is this. And what's new? Creep shrinkage models for load history deflection. Some of the things, pre-compression check for post-tension sections, complete description, click there. Vibration analysis have been improved. And all these softwares that we get in our company, we validate that. We ask some engineers, young engineers as the volunteers, who just take simple models and run those just to make sure that they can validate whether the software is okay or not, rather than blindly accepting that. Similarly, RAM connection, we can now use these column brace joints. And I do a lot of reviews and people are up to date. Very comprehensive calculations that I get with the pictures like this. And you don't have to design by hand anymore. All these software programs are these softwares are pretty good. They can design all these connections for you and make sure that code checks are satisfied also. Similarly, RAM elements, they have included that 31819 design in there. We were doing a project until a few months ago, and this 31819 was not incorporated. As I said, that there are substantial changes in the shear design of ACI 31819. Now that the new version is there, we can make sure that our concrete design is per the latest codes. RAM-S beam is a simple version. Basically, if you want to use a simple span beam, then you can use this program. SAP 2000 have been modified also. And I will not go through the details. You can read through it. Aluminum frame design. US 2022 has been added. E-tabs. And they have also modified their shear wall design per the ACI 31819. Side plate system improvements are there. And side plate is a moment connection basically for steel members in the seismic zones, highly seismic zones, so that your yielding region of the beam is outside the column joint. SAFE, which is a very, very commonly used program for the design of the slabs and the mats. They have also added 31819 now. So you can design with confidence if you're using that program. Tekla TEDS is a good program. It's a simple program, basically, just like hand calculations. Version 2021 is out there. They have corrected the bearing pressures for the rectangular footings. Rigid diaphragm force distribution has been addressed. Rolling load analysis is there. And also, the key in all these softwares is that ACI 31819, the shear provisions have been added. And since Miyasa is there, just quickly, I mean, what we were taught based on the British codes was that the concrete strength was 0 and you design steel stirrups for all the shear, basically, but American code was against that. They had their own things, you know, it looks like they're coming back to what we were taught almost 40 years ago. So updated column base plate design is also there. Structure point mats, these are very, very good softwares. These are simple softwares, cheap. Anybody can get those. There are several versions of those. There is SP mats, there is SP columns, SP beam, SP wall. And here I'm going to talk about this SP mats. Basically, there's a new user interface now, much more advanced graphics. You can see that. The older versions were not very nice. Now they are becoming compatible with the other software. New modeling and meshing systems are there. And as I said, this is a very cheap software. Punching shear check is not supported at this time, but hopefully it will be in future releases. So you could click there for the complete description. The next program is the Struware, which is a very, very good program to check the code. So basically, the version is out there is 2021. What's new? IBC and ASC 716. IBC 2021 is already there, and ASC 716 is there. Rain loading has been modified. So the beauty of this program is that you put your wind loads, wind pressures, height of the building, length of the building, and it will calculate and the shape of the building roof, and it gives you all those loadings for the component and claddings. It gives you the seismic loads for that particular area, for that particular building. So a lot of calculation is already done for you in this. So wind on the solar panels also is there. If there are a lot of solar panels, how do you address those on the roof? What are the wind loads you use for that? Wind and seismic forces, it calculates at the floor levels. This is how it looks. So Simpson, Anchor Design, they have their own programs. This is their latest version. Hilti has their own program, Profis, very nice program. It can design the base plates for you. It can design your cast in place anchors or post installed anchors. And it gives you a good complete report based on the egg distances of those anchors. So all of this information is there. Well, the key here is you have to know what is out there. And our attempt was, at least today, just to make you aware that what technology is being used, what the other engineers are used, what software is there. You may not have access to all this software, but at least you know, I mean, what are the capabilities, what are the latest versions. So with that, we conclude, and thank you very much for your time. And if you have any questions, we will be glad to answer those.
Thank you very much, Javed Saab. It's, I mean, the lecture was excellent. You have given so much stuff in just 90 minutes. It was difficult to digest. At least I will have to see the lecture again. And I've also got a lot of requests that I should email this lecture to some people here who have made the request. So I just want to first make one announcement that it is not the policy of Pakistan Society of Civil Engineers to email any presentation to any individual. On the other hand, we have, for the convenience of all our associates and the civil engineers, young engineers, all our lectures are placed on our YouTube channel. They are free of charge. You can access there. And these lectures are also available on our website in a sequence. So you people can go there and you can read the lectures there free of any charge. So, but email, it's very difficult for us to email the lectures to any individual. Thank you very much. Doctor, we have a bunch of questions and please be brief in your answers. I know it's difficult to shorten the answers on the technical questions, but we can maximum go up to 20-25 minutes more. Then we have some problems with the recording. So kindly try to be as brief as possible. The first question I have was on the Facebook from Shafiqur Rahman. He's asking, he has two questions. So one by one I will ask. In USA, how many parties are usually involved in verification of structural design of a project? That is local authority, client, contractors, engineering department, etc. Any practice of providing lifetime structural stability certificate from the original designer as we do in Pakistan?
Well, there are several processes that we've, did I understand the question correct?
Yeah, I mean, the question is how many people check the design?
Oh, okay. Okay. Yeah. Just to give you an example, it depends from state to state. In California, they have the design reviewers, independent checkers who just check each and every of your calculation. In Texas, if we do, particularly for small cities, they don't even have any engineer there. So they just count on you, as the engineer to make sure. But just to give you a quick example, I'm doing a very advanced manufacturing facility in Texas somewhere. And the construction cost, the total cost of that one facility alone is $17 billion, billion, like B. And we have almost 200, I don't know how many engineers are working on that. And so there's an extensive review process that we have. Everything is so detailed there that even if you're designing some small rebars, on a small slab, there is 30 pages of calculations there. So there's because that requirement came from the client. The city did not have any requirement, but the client had those. So there are 4 or 5 processes that you have to follow to make sure that all the quality control has been done. If you do a project in Houston, the city of Houston, sometimes they look at it, sometimes they don't, and they approve those drawings. But California is the only state that I know which have these strict requirements for checking.
Thank you, Jai Saab. Now, the second question is again from Shafiqur Rahman. He's asking to get a SE or PE certification to practice in USA. What is process and how can we get this certification in Pakistan? What are the fee and procedures?
Okay, first of all, very first exam that you have to pass is the EIT, Engineer in Training exam. So basically that is a general 8 hours exam, which includes everything. It includes civil engineering, mechanical, electric, thermodynamics, you name it, right? It's there. I did it. As soon as I graduated from the university, I did that because if you ask me anything about thermodynamics now, I will fail easily. I can assure you that. So as soon as you get out of your school, you can, that is the first exam you need to pass. Then there's a PE exam, which is another 8-hour exam. And the fees are not that much. There's a agency called NSCC or whatever, National, yeah, something like that. And they conduct that exam. So that is an 8 hours exam that you have to pass. Then to become an SE, you have to pass 2 more 8 hours, 16 hours exam. So you have to do all that. And then, you can be given the certificate of a, they will, then only you will pass the exams. Then you have to apply to the state board to get registered as a PE or SE, depending upon the requirements of that state. So state board has their own requirements. You need references, you need certain experience in that field and all that. And once you satisfy the requirements of experience, then they will give you the PE or SE license. Yeah, as I said, I am registered in more than 20 states. One license does not work in every state. And I have to renew these licenses every year, 2 years. In fact, I have a spreadsheet on my desktop which alerts me that which state is coming in now, and their PDHs we have to do, 15 hours per year at least. So those are all the requirements.
Thank you, Malik Saab. Now we are going for some technical questions contrary to the topic. People have asked some technical questions which might require some answering in detail, but please try to curtail it because I have to finish it in another 15 minutes. Thank you. Muhammad Imran is asking, what are good practices of ACI regarding stocking materials on construction site?
On the structural site, the good practices are that you should not stack the material more than the design live load. So if you are designing a high-rise building, you need to, the live loads are not that much. Typically for an office building, the live loads are generally 50 PSF. So you need to make sure that your load is less than that, unless you shore that floor to the lower floor and to the lower floor. Then you can maybe stack a slightly more load, but the load needs to be distributed over the floor. The other day, I got a photo from the site where that was just a progress photo, and I saw the material stacked on the roof of a building. And the very first thing I did was call that the contractor and told him to remove it immediately. He cannot stack it because the roof is not designed for stacking. The floor has a limited capacity. So you have to follow your live loads basically.
His second question is same with Muhammad Imran. Is it a good practice to apply live load reduction in high seismic zone?
Absolutely. Live load has nothing to do with the seismic zone. You need to apply that. If you are designing a high-rise building, let's say the design load is 50 PSF, you need to reduce it. Otherwise, your structure will become very, very expensive and your competitors will win that project because their design is economical. So you can reduce the load. From that 50 can be reduced to 25. Previously, even some codes could let you reduce that to even 20 PSF, but I don't think that is there anymore. So 50% is the maximum reduction for the columns that you can do. Even for the beams, you can do that up to 40%. So 50, you can reduce to 30. Yeah, absolutely do reduce those, yes.
Now his third question is again, that might require some more in-depth your answer. So it is, why wind load factor is 1?
The reason it is 1 is because previously the wind loads used to be service wind loads. And now they have changed the wind loads to ultimate loads. So like all the ultimate loads, the factor is 1. So, you want to expound more on that?
You can do anything. You can choose a wind return period, like you can design for a storm that occurs every 25 years, but then you will have to use a higher load factor to guard for a storm that may be higher than those. Now the current philosophy is they use like a 1700-year return period storm. So a storm that can occur once in 1700, and they are going for some building up to 2400. So if you're designing for that, then we use load factor of 1. So the answer is you could use a lower wind speed with higher load factor or higher wind speed with lower load factor.
Okay, now we have Nabil Ahmed. He asked, why do we switch to PSHA or DSHA? This is the seismic hazard analysis, probabilistic and development of seismic hazard analysis for assessment of earthquake loads. Did you get the questions clearly? Should I say it again? Why do we switch to PSHA or DSHA for assessment of earthquake loads?
Well, I don't have good knowledge about this subject, but I think what you are talking about is probability-based design or
Exactly.
yeah. So again, there are sorry, not probability, performance-based design. So for any project, you can go with the performance things. Like remember when I was talking about seismic load, I talked about how soon you want to occupy the building and whether you want the building to be continuously in service and all that. So you go and set your own criteria for the performance of the building, and then according to that, you come up with the loads. And I'm not an expert on seismic design, so I cannot go too much into the details.
Mhm. That's all. Okay, Dr. Saab, anything contrary to the topic, I think you can be very brief there. Now we have another question from Muhammad Imran. Could temperature and shrinkage reinforcement be more than flexural reinforcement?
Oh, absolutely. As I said, I mean, we are used to the conventional design. I mean, as I told you, I'm designing this multi-billion-dollar facility, which is going to, I mean, manufacture some very, very advanced things in there. And the building is almost 3,200 feet long, which is 3/4 of a mile, 3-story. And the owner did not want any expansion joints in there. And the expansion joints were located at 2,200 feet. So we had to do a very comprehensive temperature analysis. Half of our hairs were lost in that, and the loads were substantial. So they did control the design, yes. And in addition to that, creep and shrinkage also for those long spans, even though we were able to put some pore strips there or whatever, but still, I mean, they did control the design, yes. So, I mean, you have to look at the special conditions.
Thank you, sir. This is now Nabil Ahmed asking, in relation to earthquake load, when do we need to incorporate the soil structure interaction phenomena in our design process?
So you want to do that?
Okay. Again, well, I have not seen codes requiring soil structure interaction for every design. A lot of times these are done to achieve economy on structures, and more we are trying to do dynamic analysis to gain economy and come up with better structures, and these are related to that. But they may not be required for you to do on every structure. It's up to you if you're trying to do a more sophisticated analysis to get a better structure or a more economical structure. So it's more related to dynamic analysis and stuff.
Now, next question again is from Nabil Ahmed, and I think Malik Saab would like to answer it. Would you please comment on airplane crash analysis for a building? How do we simulate such load? Did you hear the question? Would you please comment on airplane crash analysis for a building? How do we simulate such load?
Well, I think that, I mean, I will just skip on that. I think that is a special topic. It's a very detailed topic and we cannot address it.
Yeah. I think better. I mean, anything contrary to the topic, we should not discuss at the moment. We're very hard pressed for the time.
Yeah, I mean, we can give a special, I mean, honestly, I mean, as I did 2 years ago, that blast resistant design, I mean, lecture that I presented, we could do a special one on this also, but I think that will be
later on. So next is from Muhammad Imran. Why splices of spiral reinforcement shall be applied through mechanical and welded methods of yield strength of spiral reinforcement is greater than 420 megapascals, and why ACI imposed maximum spiral yield strength up to 700 megapascal. Did you get the question?
Yeah, but I mean, this is one of those things, very honestly, which, I mean, as engineering managers or design principals, we don't have the answers to all. So if this question was given to me, I would have just given it to a young engineer to dig through the code and just report. I don't know what the requirements are, very honestly, for the spiral. I
Okay,
rarely
okay.
personally use spirals. We typically use these ties, and I mean, based on these high strength materials that are available, they are allowing you to use these for certain members. For certain members, you cannot use those. For seismic design, they put a limit on the grade of the steel and the splices and all that kind of stuff. But I do not know the specific clause that they are referring to.
Okay, Imran is asking, I think, a similar question. Maybe I don't know whether you will answer it or not. What is the maximum value of yield strength and tensile strength of a bar that could fall below the deformed yield and tensile strength as per ASTM? I think this is.
Below this strength?
What is the maximum value of yield strength and tensile strength of a bar that could fall below the deformed yield and tensile strength as per ASTM?
I think this looks more like a trivia question. I don't know the answer.
Very
But all the testing that we do in this country, our typical strength are typically 10 to 15% more than the minimum yield strength specified by the ACI. So it's not less than that. I don't think.
Okay.
Yeah.
Okay, we skip it and we go to the next question. It's again from Imran. Why ACI 318-19 prescribes maximum amount of shear reinforcement in beam? What type of failure would happen if we exceed upper limit of shear reinforcement, which is imposed by ACI code 318-19 in a beam?
I don't think, I mean, they are just trying to make sure that you do not pack a small member with a lot of reinforcement and exceed the limit. So there's, I believe, always a limit. It used to be when we were doing these high-rise buildings, it used to be what, 8 or 10 square root of FC prime. So basically what they want to make sure is that you increase your member size beyond that. You don't start packing your small member with a lot of rebars, just increase the member sizes. So that's what they're trying to ensure.
Okay, Malik Saab, Imran, I'm skipping your another last question because I think it is also very basic in nature. I want to take another important question which has come from Muhammad Ali because I'm very short of time now. Malik Saab, he's asking Muhammad Ali, which is the primary software used for the design of RCC beam frame system? Is it ETABS?
In our office, I mean, we have, as I said, I work with engineers all over the world, and we were actually interviewing some people. It depends upon the local office. In our particular office, we use TAD and we use RAM system. If you go to our California office, people use ETABS and SAP. If you go to our Chicago office, they use RISA 3D. So it depends upon, and we have licenses for all of those. But the key here is that to make sure that if you are choosing a team, then you need to choose those people on that particular team who are familiar with the software that you want to use for that. So I mean, like we did this we did this new electric vehicle facility, and the engineer said that he wants to use a RISA. We said no, because we are using STAD and we cannot check your results based on that. So we need to make sure that we can go through the model rather than start learning another software. So you can use any software that you are comfortable with. All of these softwares are very good.
Last two questions. Let me see, one more has come. I see which is the important one. Can you provide some well-known technical institutions for learning Revit in US?
There are several. Every community college here basically offers that course. So you can check the curriculum of any technical college, and there are courses there. There are private institutes there that teach you that. And of course, the young graduates in school, they are learning that also.
Malik Saab, now this is going to be the last question. It's from Shafiqur Rahman. He is a viewer on our participant on Facebook. How much mechanical couplers are used in US how much mechanical couplers are used in US? Is there any risk involved related to construction? Any special trained labor required?
Okay, very interesting question. I and Dr. Asif, we worked on a concrete building, which was the tallest concrete building in the world at that time. And somehow we, in our mind, we had this mindset that we are not going to use any mechanical coupler. So for that tallest building at that time, we did not use a single mechanical coupler. But now I am seeing increased use of those. One project that I'm working on, almost everything is instead of on hooks, they're using these what is those cars? Headed bars. So use is increasing every day now. So I will say on this project, I'm almost seeing 50 to 70% splices with mechanical splices. So there's no risk there because these are well tested. Things. So I don't see any issue with that. It's just the cost, whether you can justify the cost of those or not. And then they should be installed properly also.
Dr. Wahidi and Javed Malik Sahab, thank you so much for patiently answering all the questions. I would like to thank you again for such a excellent lecture, and you have in 90 or 100 minutes, you have given such a high quality lecture with so much stuff that it was frankly speaking difficult to digest in such a short time. But I think people can watch this lecture again on our YouTube channel, or this is on our website, and they will learn more and more from this lecture. Now I have to make 2 announcements, and then inshallah we will close this lecture. Next lecture is on 17th October 2022. The topic is structural engineering, search for simple facts beneath complex, and our speaker is engineer Rizwan Mirza. Certificates can be collected from 14th September 2022 from 148D Faisal Town Extension, Lahore, which is our office there. And before coming, you can ask, you can call on 0347 462 5111. I repeat, 0347 462 5111. And the person to contact is Ahmad Akram. Dr. Wahidi and Malik Saab, your shield and your certificates, inshallah, will be sent by courier mail by Sadia. I think in probably on Monday or Tuesday. And I think by the end of coming week, you will receive your shields and your certificates. And I thank you again. I still have questions with me, which due to shortage of time, we could not answer. Inshallah, I would recommend to all the participants, if they have more questions, please email those questions on psce@pesce.org.pk. We will inshallah email those questions to Javed Saab and Dr. Saab, and they will inshallah answer those questions, and we will send you the response. So thank you very much for being with us. We have, I hope, Dr. Saab and Javed Saab have enjoyed giving this presentation as much as we enjoyed listening to it. So thank you very much. Allah bless you all, and see you on 17th October. Thank you.
Thank you very much. Thank you very much. Assalamu alaikum.
Assalamu alaikum.